Okay, this is question 9 from exercise 7E. It says an aeroplane is flying due north. So the aeroplane is flying upwards like that. But to avoid a storm, so it starts here going towards A, but to avoid a storm, it flies on 150 kilometers on a bearing of 60 degrees. Now we need to see where this 60 degrees is. Where do we think that is? So the plane was going like this. So the plane was flying like this, and then it diverted and went over here on this bearing. Where is the 60 degrees? Bearings are measured from where? So the plane's here flying towards A. It stops. There's a storm in here. So it goes around the storm like that, okay? It stops at A. It turns. So bearings are measured from north, so therefore this angle in here is 60 degrees, okay? So this angle is 60 degrees. So the plane comes along here on this bearing of 60 degrees. It flies 150 kilometers. It then stops. Remember, the plane actually wants to go from A to C. But there is a storm here where the red dotted lines are. So he goes around the storm, or she, the pilot, goes on a bearing of 60 degrees. All in here is 60 degrees. The plane then gets to B. He then changes direction and flies on a bearing of 320. Obviously, this angle in here, angle ABC, is not 320. Bearings are measured from north. Notice at B there is another north sign. The bearing is, if you watch clockwise, this angle all the way around there is 320. Okay, now I'm going to draw that on this page, and we're going to fill in these angles. So we've got A, we've got B, and we've got C up here. Now, the plane, so I'm just going to, so you have to find the angles A, B, C, and angle ACB. So they want those angles there. So this was the diagram. We know that it flew on a bearing of 60. So it was going this way. The plane starts here. It goes up to there. When it gets to A, it changes direction. And this angle in there is 60 degrees. Okay. It then comes along to B. It stops. It changes direction. And this whole angle is 320. Now, when you see two north signs, all right, now the problem is I only know that, yes, I know that's all 320. I know up to there is 180. But I don't know the rest of this. I do know some of it, but when you see two north signs, girls, start looking for alternate angles or co-interior angles or something like that. This angle down here is 60, so I'm going to do a Z. What's this angle here? 60, okay? So that angle down there is 60. I'll just rub out this 150 for a sec. That's a distance. This whole thing was 320. So, girls, what's the straight line bit of the 320? So I'm going to go 320, take away 180, take away the 60. Do you know why I'm doing this? Will give me this theta in here. That angle in there, all of it is 320. If I take away that 60 and that 180, I'm left with the theta. Okay, so the whole thing's 320. It's made up of three sections. This section here is 180, this section 60, this is my unknown section. So therefore, theta is 320 minus 180 minus 60, which is 320 minus 240, which is, okay, girls, so this is 80. Do you know now what this angle here is? If that's 60 and that's 80, what's the remaining angle up here? So therefore, they wanted angle CAB was 60. I'm going to write them all out. Angle ABC was 80. And therefore, angle ACB is 180 minus 80 minus 60, which is 40. Okay, so this angle in here is 40. Okay, now you can do whatever you want. So let's draw the triangle again. We've got 40. So looking at this triangle again, we've got 40, we've got 60, we've got 80, and we know that this distance here is 150 kilometres. So what's part B of the question asking you? Yeah, so part A was to find two of these angles, but we've written them all out. And part B is asking you to find the distance BC. Now, sine rule. We're going to try sine rule. We're going to use our double-sided arrows and look for pairs. So part B was asking to find the distance BC. So here's a pair. I've got 40 degrees is opposite 150 kilometres. I'm not asked for AC, but I'm asked for BC. So 60 degrees is opposite, I'll call it D for distance. Actually, I can call it little a. It doesn't matter what I call it. All right, but it's BC. We ready? So how do I do it? How do I set it up? D over, or I can call it BC. Do you know what I mean? It's a side. BC over sine what? 60 equals 150 over sine 40. We're using the A over sine A equals B over sine B version because we're finding a side length. Got it? All right. So therefore BC, or little side length D, is 150 over sine 40 times sine 60, because the inverse operation of dividing by sine 60 is to multiply by sine 60. And what distance do we get? Just tell me what it is. 202 point. Let's just go 0944. Let's just go maybe to 1. I don't know, or to the nearest. I don't know what they want. So therefore it's 202 kilometres to the nearest whole number. Or do they want, yeah, that would make sense. Instead of travelling from A to C, the plane had to go from A to B, then from B to C. It obviously had to travel further. So now the next part of the question is to calculate the extra distance travelled by the plane. Now to be able to do that, you're going to have to work out AC. So you're going to have to use sine rule again. Now, when you use sine rule this time, please don't use the D answer with the 60 degrees, because that has been rounded off. That is an approximation. I would use the ones that you definitely know. So calculate the extra distance travelled by going via B. Do you know what I mean? So let's calculate AC first. So I'm going to draw it again. I've got C, and we've got A, and we've got B. I want to work out AC, so I'm going to use that. Look, I could use this side, but I'd like to use the other one. Do you know why I want to use the 40 and the 150? Because they're whole numbers. You've just calculated BC. If you go and use that answer, round it off, you're introducing error into your question. Do you get that? So if you want, you only need to use two pairs. One full pair. Oh no. Oh no. Just one sec. Sorry, there was a bit of a interruption there. So we want to find out AC. AC over, I want this distance, over sine of 80. AC over sine 80 equals, let's go, 150 over sine 40. They are not rounded. That's why we choose to use that pair. The other pair is a pair, but if you were to use the 202 kilometres and the 80, you'd have to use the non-rounded version of the 202 kilometres. So it's just much easier to use the original data. So therefore AC is, yeah, what does it work out to be? 200 and? I'm just going to keep it at the moment. So therefore the extra distance travelled is going to be 150 plus, I'm just going to go the 202.094, etc., minus 229.813 in case we do get any rounding errors. So use at least a couple of decimal places there and here as well. So the extra distance travelled is 122.3. Is that what you're getting when you subtract? 128.28, etc. So therefore it's 122 kilometers to the nearest approximately, that's your approximately symbol, to the nearest kilometer. Question 10, it says a ship is starting from A, it heads due north to point B for 40 kilometers, and then it changes direction and goes on a bearing of 100 degrees. So if we're at B, you put a north sign clockwise, this angle here is 100. Now if this angle up here is 100, what's this one in here? 80, because you've got a straight line. So this angle down here is 80. So it goes on a bearing of 100 degrees till it gets to point C. It now says that the bearing from C to A is 240, meaning that from C, put a north sign, go clockwise. This whole angle that I'm marking out now, so from here all the way round, is 240. Now, if all that's 240, watch what we're doing here. How much have I gone so far? 180. So what's this angle in here? 180 plus what is 240? So this angle here is 60. This angle here is 80. Remember? What else can I work out this one up here where my cursor is? That's 80 by alternate. And now you can work out this angle in the triangle. Did you know actually you can work out this one down here as well, watching. If the whole thing's 240, then where my cursor is 60, right? When you see two north signs, why don't I do a Z like this? What's this one down here? Yeah, if this one in here is 60 where my cursor is, then if I do a Z, this one's also 60. I've got 60, I've got 80. By angle sum of a triangle, you can work this one out anyway. All right? So you can work out this one in here two different ways. All right? So the question will ask you to calculate the angles, and then you've got to find some distances. Okay? Again, same thing. Write your bearing in and then look for alternate angles or co-interior angles. Remember, co-interior add up to 180. Alternates are easier. Alternate. So you've got three things to look at. Straight lines make up 180. Alternate angles are equal. But you've also got co-interior. So I can go from this north sign to B, down to C, and back up to north. That's a co-interior angle. Okay?